Hi, Chris. Thank you for joining me in today's discussion. Before we deep dive into the technical challenges, can you start by sharing a little bit about yourself and your background with Starline and expertise in power distribution, please?
Yeah, first off, thanks for listening, everybody. My name is Chris Osian. I'm currently a product manager for Starline Busway, a brand of Legrand. My background is for the first 10 years at Legrand, I was serving as an applications engineer, specifying power distribution equipment, i.e., Starline Busway, to all types of data centers, anywhere from like an MDF room all the way up to hyperscale accounts and large scale enterprise data centers and lease spaces. And the last 2 years, I've been serving as a product manager for our Starline Busway system, specifically for the data center space. And I also manage our power monitoring line as well for the data center space. So that is my background. In sum, I have about 12 years of experience in power distribution equipment.
Great, thank you so much. So, from your perspective, how do you think AI-driven growth is reshaping power demands in data centers today?
Yeah, I think power demand driven by AI is no secret, right? Like the last 2 to 3 years, we've seen significant increase in power demand by racks and all of the upstream infrastructure that comes with it. Let's say 5 to 8 years ago, 7 to 10 kilowatts was a pretty common space for racks. Fast forward a couple of years from that, it had turned into 15 to 30 kilowatt racks. And today we're deploying, 43 to 50 kilowatt plugins right now. And we're getting requests now for even higher than that. We're getting requests between 100 kilowatts and 150 kilowatt racks. And in talking to customers in the field, we really see no slowdown there, right? We're being told that it's going to continue to increase in the future, and there's going to be no slowdown whatsoever in the power demand based on the AI boom.
Mhm. Definitely is that. So, as AI drives higher power densities, what are some of the key safety challenges for data centers?
Yeah, so it all centers around higher power density, right? When you have higher power density, it really affects two things with respect to safety. One, it increases fault current, and then two, it also increases arc flash, basically incident energy. So when you're working on electrical equipment, there's a little bit of higher risk now that we're seeing more power demand, and you have to manage and train your employees to deal with those type of risks. Um, some data centers are even opting to shut down any installation of electrical equipment to do the work on equipment. So, with respect to key safety challenges and AI, we're really seeing an increase in both arc flash risk and fault current risks as well.
So, on that safety note, why is safety critical in high density power environments and what are the risks of neglecting it?
Yeah, great question. And I don't think it's just high density power environments. I think safety is critical no matter what, no matter whether it's low power or high power. Like I said, like I mentioned earlier, I think what happens in the AI boom is that once you have higher power, higher power demand, i.e., more incident energy, more arc flash risk, and more fault current risk, the risk of neglecting it is one, equipment damage if you don't spec appropriately, and two, personnel safety and injury as well. So it's critical that organizations are paying attention to this increase in power demand, but also the safety challenges that come with it. And to talk about that a little bit more, once you have an increase in incident energy, what that means to your personnel in the field is that your arc flash boundaries also increase, right? So the risk of, again, the arc flash risk is increased from compared to what we had before. So you really need to ensure that your personnel is trained to deal with that increased incident energy, to know where their arc flash boundaries are, to know what PPE to wear. And so those are the kind of the critical, I would say, safety aspects to be aware of when you're dealing with high density environments.
Great to know. Yeah, thank you. And how do you think Starline enhances safety in these environments, in AI-driven high density power environments?
Yeah. So we've been looking at this for some time. Again, the AI, I'd say, boom, or the AI, driven increase in power has been prevalent for about a year or two now. And so we've been working on making our equipment safer. One of the pieces that we've implemented this year is something called the remote plug-in actuator. And what that does is it allows us to add a circuit live and in the field without the user actually being present at the location of that piece of equipment. So if you're familiar with Starline busway, we house circuits in our plug-in modules, and this actuator allows us to add that circuit to the busway, not electrically engage it yet, allow the installer to step out of that arc flash boundary to a safe position, and then they can actually install the electrical connection and add that circuit in the field. So it makes installing and removing circuits live much safer than it was before. And I'll, for those maybe not familiar with the Starline busway, we are designed to install live. This remote actuator is just a mechanism that allows us to offer an extra layer of protection to people that are installing circuits in the field. And on top of that, one other solution that we're working on as well is with this AI boom, we are seeing an increase in liquid cooling within the data center as well. And, again, rewind 5 to 10 years ago was predominantly air cooling then, but now we're introducing liquid cooling into the data center space. So in order to protect equipment, we've seen some interest in IP54 busway, which we offer today. And our IP54 busway is a splash-proof busway that allows for harsher environments to be installed in harsher environments. And so with this AI-driven boom, to summarize, we've seen a shift from air cool to liquid cool, and we're now seeing more interest in busway that's a little bit more protected against harsher environments.
Thank you. You talked a little bit about your solutions there. So I wondered what key innovations in Starline solutions help protect against electrical faults and manage increasing power demand.
Yeah, so specifically for monitoring and getting good visibility on power demand, we have released an M70 power monitor that lets you monitor real-time current, voltage, and power. And I think the key safety aspect there is that it allows you to set critical thresholds within the monitor and alert users when these critical thresholds are met, basically giving you real-time data and alerts to when something goes wrong in the data center. But not only that, it gives you the ability to monitor your trip points, see when a breaker trips, and also has a thermal sense with it to ensure that your thermal management is under control as well. And I'd be remiss without talking about kind of the resurgence of fused solutions as well. Fused solutions have been around a while, but I think this AI boom has really, again, skyrocketed fault current and available fault at certain points in the system, including busway. And so Starline offers right now fused solutions both within their plug-in unit and upstream further at the beginning of the busway at the infeed to allow basically faults to be mitigated at the busway system. And when you mitigate the fault at the busway system, overall, you make the equipment safer and the incident energies lower as well.
Thank you. It's really interesting use of technology and obviously extremely innovative as well. Now, if we turn to look at the future, how will power distribution technology evolve, do you think, to meet future safety challenges as power densities continue to rise?
Yeah, and I think so. It definitely starts with increasing power infrastructure to meet that demand. So we're definitely looking at ways to again satisfy this increasing power demand even beyond what we offer today. I think innovation around safety really needs to happen around mitigating fault currents. Like I said earlier, there's no slowdown that we're seeing with this rise in power demand. So really looking at ways of mitigating faults, whether that's OCPDs, current limiting devices. I think that's one key mechanism we can look to the future on again mitigating faults. But we also need good visibility on systems, right, to ensure that anomalies are detected quickly as well. Not only with the aforementioned monitoring device I said, but we can also look at monitoring different points in the system as well that maybe are less monitored. And then lastly, I think, and most importantly, I think education and training are going to be super critical with these rising power demands, right? I think we're entering a new territory where the rising demand is not something we've seen before. And again, it's not slowing down. So we always have to look at how to mitigate the risk via equipment, but also train our organizations to deal with that increased risk as well.
Thank you, Chris.
Yeah, thank you.